This is Daryl with Cisco Hands-On Training. It's the 28th of February 2009, and today we're going to talk about VTP, which is the VLAN trunking protocol. My website's ciscohandsontraining.com. I'll put the diagram on the website in the comments area, although it hasn't changed for the past couple episodes. In iTunes, search on Cisco Podcast, and you'll find me near the top. I always appreciate people linking to my webpage. One administrative note, I have 13 old episodes that don't play on iPhones, for example, and I apologize for that. I'm going back and remastering them but to the correct format, but that means that unfortunately, due to the software I'm using, some of the older episodes are ending up out of order in the podcast. So just please cope with that until I get that all sorted. Let's see, some cleanup stuff from last episode. The first was, what precisely does Loopguard do? And we saw some behaviors. With Bpdu guard, if you receive a Bpdu on a port with Bpdu guard enabled, it shuts down the port. And that makes sense, because if somebody plugs a switch in, you don't know what it's going to plugs a switch into a place where it's not supposed to be. You don't know what that switch is going to do to you, so you just want to disable the port. Root guard acted different. Root guard is where spanning tree, at least on the Cisco, is a per VLAN spanning tree, or at least that's what we've been learning so far. And so you have a separate spanning tree instance for VLAN 1 and VLAN 2 and VLAN 4, and those are the three VLANs we've been working with. And so if you receive a Bpdu on VLAN 4 on a port which says, hey, which would cause you to make the root go out that port, and you have root guard enabled, you want to disable, you don't want to accept that on VLAN 4, but you don't want what you received on VLAN 4 to mess up your other VLANs. So you don't shut down the port completely. Instead, you just put that VLAN on that port into root inconsistent mode, and you basically block that port in that VLAN on that port in spanning tree. And so that's the behavior that we saw. There was one other behavior we saw, which was sort of a side effect. And so let me skip down here. What happens to a layer 3 VLAN interface when there are no layer 2 ports or trunks carrying that VLAN? So let's go ahead and show VLAN, and I have VLAN 1, VLAN 2, VLAN 4, and show IP int brief. And in a layer 3 sense, I have IP addresses on VLAN 1 and VLAN 2, and both of those VLANs are up. The status is up and the protocol is up. Those are layer 3 ports. So let's show VLAN ID 2. And VLAN ID 2, we have ports on VLAN 2 in fast Ethernet 0/2 and fast Ethernet 0/3. Show run int fast 0/2, show int trunk. So fast Ethernet 0/2 and 0/3 are both trunks, and they're in mode auto, and the other side is desirable in the dynamic trunking protocol, so we're trunking. And all VLANs are allowed on the trunk. So what do we want to do here? We want to see what happens to the layer 3 VLAN 2 interface when I don't have any ports on VLAN 2. And here I have 2 ports where VLAN 2 is allowed. So conf t int fast Ethernet 0/2 switch port trunk allowed VLAN, and then I can add VLANs, I can remove VLANs, or I can give a complete list of VLANs that are allowed. So let's remove VLAN remove 2. I'm going to go back and look at my config. Show run int fast 0/2. So by removing VLAN 2, now I did not have a switch port trunk allowed command previously, and we have not studied that previously. By removing VLAN 2, now the switch port trunk allowed allows all VLANs except VLAN 2, and the max VLAN that you can have the 802.1q trunk is 4094, and so VLAN 2 no longer exists on that trunk. So show IPnt brief. Now my layer 3 interface for VLAN 2 is still up, and that's because the VLAN still exists. I'll go to a show int trunk, and you can see that fast Ethernet 0/3 still allows VLAN 2. So let me do something different on VLAN fast Ethernet 0/3. Conf t int fast 0/3 switch port trunk allowed VLAN 1, 4. So instead of removing VLAN 2, I explicitly allowed only VLANs 1 and 4. So show run pipe begin net 0/2. Okay, so here's the two configs. In one, I removed VLAN 2, and so switch port trunk allowed VLAN 1, 3 to 4094. In the other one, I explicitly allowed just the VLANs I wanted. And now show int trunk, and you can see VLAN 2 is not allowed or active in the management domain on any ports. And then show IPnt brief. And you can see that VLAN 2 is now in a protocol down state. So this is a side effect. What we did is we took VLAN 2 off the trunks, but in the end we had a switch where we had a layer 3 interface on VLAN 2, but we did not have any ports on VLAN 2. And Cisco is smart enough, when you don't have any ports on VLAN 2, then it puts the layer 3 interface into a down state. And that's useful in multi-layer switch routers. So if you got like a Cat6K and it's routing to VLAN 2, so it's advertising that subnet out into OSPF, and then all of your ports on VLAN 2 and all of your trunks carrying VLAN 2 go down, well, you can't deliver the traffic anywhere, right? So why advertise that subnet and attract traffic to the subnet to this Cat6K when you know you can't deliver it to anything? You know, maybe there's another Cat6K out there that also has, that still is VLAN 2 operational that could deliver it. So in that case, the right thing to do is to take that VLAN layer 3 interface, put it in the down state. That way you no longer advertise the route for that subnet. You're no longer saying, hey, I can deliver to that subnet. And hopefully your layer 3 protocol will successfully reroute to another Cat6K, which can successfully deliver on a VLAN 2. Okay, so that explains the behavior we saw with RootGuard last week. RootGuard works on a per port per VLAN basis, and so if you receive a Bpdu on a port which on a VLAN, if you receive a Bpdu which would cause a VLAN on a port to become the root port for spanning tree, and you have RootGuard enabled, then RootGuard says, hey, that I'm not supposed to make that set forward root out there, so it goes in a root inconsistent state and it blocks. And then as a side effect of that blocking, all of our ports on one of our switches on a particular VLAN went down, and so the VLAN interface went down. Now the VLAN interface going down was not directly because of RootGuard, it was just a side effect because all of the ports on that VLAN had happened to go down. So that explains some of the behavior we saw last week. So, okay, so that's what RootGuard does. Let's talk about one other feature, Loopguard. Loopguard is a feature which, and here's a link on Cisco's website which I'm going to look at for us. Loopguard is a feature which says, here is a port and I never want it to become a designated port. Now why would you do such a thing? Well, here's a typical 3-switch topology, and your root bridge is over here at switch A, and typically switch B is your backup root bridge, and switch C is your access switch, and you have your 2 uplinks. And remember that the uplinks the uplink on the left is forwarding, but it's forwarding because it's a root port. The uplink on the right is blocked, and it's an alternate port. And then your downlinks are designated ports. Remember, each link has a designated port on it, but the designated port is closest to the root bridge. So on this on this link, the port on A is designated and the port on C is the root port. On this subnet, the port on B is designated and the port on C is blocking and is also an alternate port for uplink fast. You never want these, if you have sufficient redundancy between A and B, then you never want your uplinks on C to become root ports. If they did, because, for example, C was no longer receiving Bpdus, then if you started forwarding, then that could result in a loop. So there's a feature called Loopguard, and what Loopguard says is if this port was going to become a designated port because it no longer received Bpdus from B, then something is wrong, and I do not want it to become a designated port. Instead, I want to put it in a loop inconsistent state. So let's revert our config to the original configuration and look at an example. So conf t int range fast 0/2 switch port trunk allowed VLAN all. Show run int fast 0/2. You can see we're back to the original configuration. And again, my standard config is switch port mode desirable. So let me go to my standard configuration here, as long as I see something that is not the way that I want it. T int range fast 0/2 to 3 switch port mode, and then dynamic desirable. And you notice that because I started allowing VLAN 2 on those trunk ports, my once spanning tree started forwarding, then my layer 3 VLAN 2 interface came up. Now let me pause for a minute. So here I am on switch 3, show spanning tree, and you can see for VLAN 1, Fast Ethernet 0/1 is my root port, and Fast Ethernet 0/2 is my alternate port. Show run int fast 0/1, show run int fast 0/2. Okay, so in this setup, I never want the uplinks to become designated ports. Root ports are okay. Alternate ports are okay because those are blocking, sort of like candidate root ports, but designated ports, bad. So let me enable Loopguard on the uplinks. Int range fast 0/1-2, and the int range command is very precise here. Int range fast 0/1 space dash space 2, and then spanning tree guard loop. Now another thing here, a loop guard port can never become designated. A root guard port is what you would use on a port which you never want root out that way, so a root guard port is not allowed to become root. The two are mutually exclusive. So you use root guard on downlinks that are going to boxes which might be switches, but you don't want them ever to become root. You use Loopguard on uplinks from your access switches if you never want them to become designated, and that means you never want to route traffic through that switch. And then, of course, you use Bpdu guard on ports that are downlinks that go to ports that should go to end hosts, and nobody should ever plug a switch in there, and if they plug a switch in there, you just want to turn them off. Okay, so our spanning tree guard loop is enabled on that, and show spanning tree. And again, VLAN 1 fast Ethernet 0/1 is root, and fast Ethernet 0/2 is blocking. Let's go ahead and on this switch here, let's enable Bpdu filter inbound on this cross-link interface, so that way the BPDUs will never get to the BPDUs from the root will never get to switch C. Actually, I'm not, in that case, switch B will try to take over as a backup root, and yeah, so in that case, switch B will attempt to take over as a backup root, BPDUs will get here, switch C will say, hey, I'm receiving BPDUs from A and B, A has lower priorities, so I will continue to have the root port on the left towards A, and C would normally become a designated port, except that I have Loopguard enabled. So let's see what happens in that case. Here I am on switch 2, conft int fast0/1. I'm going to use the spanning tree Bpdu filter enable. So again, this is a dangerous command, and I'm only using it for example purposes here. You don't normally want to play with Bpdu filter ever. Here I am back on switch 3. And you can see I got there just in time to get the log message. Loopguard blocking on fast Ethernet 0/2. So again, because I'm blocking on fast Ethernet 0, or I'm filtering the BPDUs at fast Ethernet 0/1, I no longer am sending out the fast Ethernet 0/2 would normally become a designated port, and because of the Loopguard, I blocked there for a bit. So, and what's weird is I got two messages. I got the Loopguard unblocking and blocking. Let's interesting. It is forwarding, and it is designated. Not what I expected based on the documentation. Let me think about that for a bit. So at this point I have to say I don't understand the behavior. According to the documentation, if I configure Loopguard on a port, then it should block if that port goes into, wants to become a designated port. And I actually see here that it blocked it for a second, and then at least on VLAN 1, and then it unblocked it. And you can see I have spanning tree guard loop. There's a spanning tree Loopguard default command, which seems weird to me. I'm not going to play with that. So Loopguard does not appear to be working as documented. Maybe it's a code problem, or maybe I just don't understand it perfectly. I'll do some research on that. In any event, you can see that I've used the Bpdu filter to create a spanning tree loop, and I only took one Bpdu filter command to do it. And you can see my CPU, or my bridging loop here. You can see I'm running at 99% CPU. So I'm going to go ahead and restore a normal config, and we'll go on with the discussion of VTP. So here I am back on switch 2. I'll take off the evil and dangerous Bpdu filter command. Okay, let's start talking about VTP. VTP is the VLAN trunking protocol, and let's talk about what the problem is. And you can see the problem is that this switch does not have VLAN 1 on it. I'm sorry, it does not have VLANs 2 and 4 on it. I configured VLANs 2 and 4 in my other switches, but on switch 2, I did not configure it. So I have inconsistency in my network, and I do not have redundancy. And in fact, if you go back in the video and you look closely at the spanning tree for the previous one, you'll see that only VLAN 1 did the Loopguard stuff. So let's what is VTP? VTP is a protocol which will communicate VLAN information between switches, so that way you only serve it, configure it once. VTP, there are 3 different versions of VTP. Version 1 is the original version. Version 2 added support for token ring, which is historic, so it doesn't really make any difference whether you run VTP version 1 or version 2. VTP version 3 adds some new stuff, but at least we're not going to talk about VTP version 3 today because it's not supported on many devices, including the switches I have in the lab. Okay, so show VTP status. VTP has a concept. VTP version is 2 on these switches, which is the default on these. You notice config revision is 0, and that's important. And the VTP operating mode is server, but there's no VTP domain name. VTP has servers and clients and transparent mode. And servers are where you can create VLANs, and servers and clients will all share the VLAN information. So the first thing we need to do is create our VTP domain. So conf t VTP domain lab. Okay, so show VTP status. So now I have a VTP domain name of lab and config revision is 0. And then let me go ahead and create a new VLAN. Conf t VLAN 2 name, I don't remember whether it was engineering or accounting on the other switch. Name engineering. Show VTP status. So now that I've created a new VLAN, my config revision has incremented. Okay, let me go to the other switch. All switches in a topology need the same VTP domain, but you notice the VTP domain name over here, it was blank and now it's picked up lab. So it looks like when your VTP domain name is blank, it's listening, and then when you create it somewhere else, then you've created the lab domain. Let's look at our VLANs. This is interesting. VLAN 4 is gone. So what that means is that when this switch had VLANs 1, 2, and 4 on it, but when I created the VTP domain name on the other switch and created just VLAN 2, then the other switches that are connected with 802.1q trunks to it picked up that VTP domain name, which was good, but then the switch with the incomplete VLAN information, that VLAN information was determined to be correct. Now, the accounting department right now would be suffering a network outage because VLAN 4 does not exist, so any ports in VLAN 4 will be down. So conf t int fast0/8 switch port access VLAN 2 no keep alive. No keep alive is a way of I don't have any cables plugged into fast Ethernet 0/8, so no keep alive is a way of fooling the switch into keeping the port up, even though there's no cable and no link on it. And then int fast0/9 switch port access VLAN 4. It created VLAN 4. No keep alive. So a minute ago we did not have VLAN 4. Now I've created an access port on a VLAN, show VLAN. You can see VLAN 4 exists with the default name. And then show VTP status. When I created VLAN 4, the config revision incremented to 2. And then what's going to happen is the other switches, this switch now has VTP, has config revision 2 in V2P. These switches had VTP configuration revision 1. They were in the same VTP domain name, which is lab, and they're linked with 802.1q trunks, which is important. VTP only talks over ISL or 802.1q trunks. If you have switches connected with just a straight access port, VTP is not going to run over that. And then, lo and behold, the new config revision 2 information, including VLAN 4, will be propagated over to these guys. Now let's go back to our outage situation where VLAN 4 did not exist. Show VLAN. So I deleted VLAN 4 in a layer 2 sense. Remember, you have layer 3. You can have layer 3 interfaces which have IP addresses on a VLAN. I mean, you can have a layer 3 VLAN interface, which is a layer 3 interface with an IP address. And you can have a layer 2 VLAN, which is the existence of the broadcast domain, and you're running a spanning tree instance on it. So show IP and brief. VLAN 2 exists, VLAN 4 does not exist. And fast Ethernet 0/8 is down, even though I did the no keep alive on it. So not doing too well today. That works on routers. Okay, so much for the no keep alive thing on switches. Not enough to keep it alive. Okay, so where are we? We've introduced VTP. Show VTP status. We're running VTP version 2 by default, which adds support for token ring, but we don't care. We've made a couple modifications and have config revision 3 now, which now gets propagated out to our other switches. The VTP operating mode is server, which means that we can create or delete VLANs on this box. Now, servers and clients can both forward on VTP information, but only in servers can you create and delete VLANs. VTP domain name is lab, and that needs to be the same throughout your domain. VTP switches that are talking the VTP protocol, the protocol only works over trunks, so only if you're connected via 802.1q or ISL trunks will the VLAN information be disseminated. Let's go ahead and go over to switch 3 and see what it looks like over there. Here's switch 3, show VTP status. We also dynamically picked up the VTP domain name, so the domain name was blank, and then we got the new VTP domain name lab, and config revision 3, show VLAN, and you can see that VLAN 1 exists, VLAN 2 exists, VLAN 4 does not exist. So let's go ahead and fix our network outage. Actually, let's go ahead and make this a client. Typically, when I'm setting up a VTP domain, I'll typically make the 2 distribution routers servers, and I'll make these guys down here, I'll make the access switches clients. So conf t VTP mode client. Now let me try to create a VLAN, conf t VLAN 4, and you can see it won't allow me to create a VLAN because it's in client mode in V2p. So let me go back to switch 2 and create the VLAN there. Here I am on switch 2, conf t VLAN. I want to show my CDP neighbor. For kicks, I want to do an experiment. I'm going to shut down fast Ethernet 0/1. Switch 1 and switch 2 are servers. Switch 3 is a client. I'm going to shut down this link between switch 1 or 2, and when I create the VLAN on switch 2, it's going to increment the config revision, and that's going to make it to switch 3, and then that switch 3 is a client, and switch 3 will update its VTP information, but we'll see if the information gets over to switch 1 as well, which would mean that even though switch 3 is a client, it's still willing to serve out VTP information, just can't create VLANs on it. So conf t int fast conf t int fast 0/1 shut show CDP neighbors, and VLAN 4 name accounting, show V2p status. Config revision is now 4. The old config revision on this switch was 3, and so the VTP information should get from switch 2 to switch 3. And now let's go look at switch 1 and see if it actually received the information from switch 3. So here we are on switch 1, and you can see we successfully received the information from switch 2, even though we did not have a direct connection to it. So the answer is, even though switch 3 is a client V2p switch, it still serves out V2p information. So it's only, the only thing that a client does is it prevents you from creating or deleting VLANs on that switch. Okay, let's go ahead and there's something called V2b Password. So the V2b Password is not exactly a big secret. You can actually type a command, show V2p Password, and it will print out the password for you. And the V2p will only successfully exchange information between the switches if the password is the same. So conf t V2p password blah. Show V2p password. And you see it actually prints it out. So you don't want to put a very secret password in there, because anybody that gets console on the box can just see what your password is. If VTP information will only be exchanged if the password matches on the two boxes. So now I have a mismatch between switch 2 and switch 3. And so let me go ahead and trigger an increment of my config revision. So conf t VLAN 5. Oh, wrong switch. I'm on a client. So here I am on switch 3, or I'm sorry, switch 2, conf t VLAN 5 name. I don't even need a name. And you can see that now VLAN 5 exists with the default name, which is all caps VLAN 0005. And then show V2p status. Config revision is incremented to 5. And then let's go check out switch 3 and see if it received the information. Show V2p status. Show V2p status on switch 3. You can see switch 3 is still stuck at config revision 4. And it also tells you the last time a configuration was modified. And you can see the last time the configuration was modified, it was from switch 2. This is the IP address of switch 2. And show clock. Last time was from switch 2 like 5 minutes ago. And I changed the configuration 2 minutes ago. We know we created a new VLAN 5. And we know that we incremented the config revision to 5 when we did that. And we're not getting it here because our VTP passwords are out of sync. So the answer is your VTP password needs to be the same on all your boxes. Show VTP password. Blah. So generally, since the VTP password does not give you much, well, yeah, it's your choice whether to run with the VTP password or not. The VTP password helps protect you from somebody plugging in a switch into a trunk and trying to deliberately mess with your VTP domain. If I was running a university network, I'd be very concerned about such things, because you've got a bunch of college students who are have a tendency to want to mess around and stuff. So a college environment is actually one of the most hostile environments for a network manager. At an enterprise, I mean, you're not running, at an enterprise, all of your switches are in closets. You're not running 802.1q trunks out to the desktops, and you got a little bit of more, you know, if somebody does something bad, you call HR and you fire them. So it tends to be less hostile than a college environment. So we saw VTP password. Let's go ahead and get rid of it. Conf t no VTP password. show Vtp password. Vtp password is no longer configured. Show Vtp status. And we're still at config revision 4. Now, Vtp sends out updates every time the config revision change. It also sends out a summary update every 5 minutes. So if you have a Vtp connectivity problem, and it sometimes might take a while for it to fix itself, but I'm confident that the config revision will eventually increment to 5 and will be back up. Another way to force a fix more rapidly is to go to the other switch and just create and delete a VLAN that you don't care about to trigger another rev of the config revision, which will automatically get pushed out quickly. So that way, if you're impatient, I mean, I could be in an outage situation right now. I could need VLAN 5 to be online in order to have my customers working. So if it was urgent, I'd go to the other switch and just, create and delete, VLAN 999 or something like that, and force an immediate update now that I've fixed my Vtp password mismatch. I'm getting impatient, so let's do that. Conf T, I'm back on switch 2, VLAN 999, no VLAN 999, no VLAN 999. Nice if you show Vtp status. It's my config revision incremented to 7. And then here I am on switch 3, show Vtp status. And you can see that the config revision is now 7. So by just creating and deleting a VLAN that did not exist, or that you didn't care about, you increment the config revision 2 more times, triggers an immediate update, and that way you don't need to wait for the 5-minute timeout for Vtp to fix itself to get back in sync once you fix a out-of-sync Vtp password problem. Okay, what else do we want to talk about? We talked about Vtp. Version 2 is default on these switches. We're not talking about version 3 today. Version 1 and 2, the differences are insignificant, but you need to run the same version on all your boxes in a particular Vtp domain. Vtp modes, server is where you can create and delete VLANs. Servers and clients will both send out Vtp information. So, in fact, if you have a client with a config revision of 5 and a server with config revision of 4, the client's config revision will be sent out and take over the servers. And in fact, that's actually happened on our environment. When we incremented switch 2's config revision to 5, which was a server, it overwrote this client's config revision, which used to be 4. Now this client had config revision 5, and that overwrote this server's config revision, which was 4. Because our direct link between the two of them was down. Now let's talk about the dynamic trunking protocol. The dynamic trunking protocol, we talked about it last week, and it's a way to automatically negotiate trunks between boxes. But there's one thing that's in there. The dynamic trunking protocol actually uses Vtp. In order for dynamic trunking protocol to work, you need to have the same Vtp domain on both ends of the trunk. So conf t Vtp domain blah. So now I've changed my Vtp domain to blah on switch 3. And show int trunk. And you notice I've got a dynamic trunk protocol that's complaining unable to perform trunk negotiation because of a Vtp domain mismatch. So let's see what happened to my trunks. Looks like my trunks are still up at this point. Let me see if I still have connectivity. Sure looks like my trunk is down. It looks like VLAN 1 is working. So on VLAN 2, my IP address is 10.1.2.4, and the IP address of this box up here is 10.1. On that VLAN should be 2.2. And I'd feel better if my show int trunk command was showing me that the trunks were down. Show spanning tree. Let me see what it says. here I am on this switch, show VLAN. VLAN 2 exists, show IP int brief. VLAN 2 is in the up-down state, show int trunk. And you can see the only trunk that's actually working here is the one, that's actually the one going to switch 3. Oh yeah, because I shut down the other port. Ping 10.1.2.2 is my own IP, and it's down now. Ah, okay. Int conf t, int fast 0/3, switch port, trunk, allowed, VLAN all. That's why my thing was down. Let me go fix another thing in my config. Okay, so now I created VLAN 2 here, ping 10.1.2.4, and I can ping across the trunk, but I'm getting log messages that dynamic trunking protocol cannot negotiate the trunk. So that's interesting. Let me conf t int fast 0/3 shut. Give it a few seconds. No shut. So I bounce the port. Let's see if the trunk negotiates when it comes up. So the line protocol comes up. I continue to get the VTP domain mismatch errors. It's unable to perform trunk negotiation because of the VTP domain mismatch. Okay, so here's the behavior. In order for the dynamic trunking protocol to dynamically create a trunk, the VTP domain has to be the same on both ends. If you already created a trunk because your VTP domains were the same, then you change your VTP domain on one of them so it's mismatched. Your old trunk will stay up until the next time the port bounces or your switch reboots, at which point you won't be able to negotiate a new trunk. So that's what we call a time bomb. You create a misconfiguration in your network, your connectivity still seems to be working, and then 3 months later switch 3 bounces because of a power hit or something like that, and suddenly your network's not working again, and you think that there's some sort of hardware problem caused by the power hit, but the reality is that your configuration was always wrong. It was just that your trunk had previously been negotiated. So in order for the dynamic trunk protocol to work, you need to have both switches inside the same VTP domain. Now, if your VTP domain could be blank, which it actually was originally, or otherwise you could set your switch port mode to trunk, which basically says I want you to become a trunk no matter what. Don't even talk the dynamic trunking protocol. Okay, so that is. So let's see, so VTP domain has to be the same in order for the dynamic trunk protocol to work. Let's go ahead and fix our VTP domain. And actually this is interesting because right now switch 1 is disconnected from the VTP domain. The port on switch 2 is physically down, so I don't have a link between switch 1 and switch 2. And the port on switch 3 is in a different VTP domain. So right now, show VLAN. Let's assume that this is what I need for my network to function. I need VLAN 1, which is the default. I need VLAN 2, 4, and 5 for my other stuff to work. Let's assume this switch is actually not connected to the net at all. Let's assume it's off in some lab somewhere. And then I'm just messing with it. So conf t, VLAN 10, VLAN 11, VLAN 12, VLAN 13, VLAN 14, no, or VLAN 15, no VLAN 15, no VLAN 13, no VLAN 12, no VLAN 11, no VLAN 10, no VLAN 5, no VLAN 4, no VLAN 2. Now my config revision is 20, but I have no VLANs on this switch. It's just a switch in the lab, and I cleaned up the configs. I deleted all the VLANs on it. Show VLAN. I got no VLANs on it other than the default VLAN 1. And now I take this switch out of the lab. I suffer a hardware failure in production. I take the switch out of the lab and I put it in production, plug it in VLAN 1, and what do you think is going to happen? So here I am back on switch 3, and I configured it as a V2p. I configured the V2p domain name back to lab, so the V2p domain is the same. And then guess what happened a minute later? That switch that had been disconnected from the net and came back on, and because I was messing with it, it had a high config revision, but I cleaned it up and deleted all the VLANs. Well, since it had the highest config revision, when I reconnected it to the net, it won. And so now it spread its information throughout my V2p domain. The config revision is 20 on all of my switches, and show VLAN, but the only VLAN that exists is VLAN 1. None of my other VLANs exist. So my accounting department is down, all their ports are disabled because the VLAN doesn't exist. My engineering department is down because the VLAN doesn't exist. And whatever other VLANs that I needed for my customers, they're all down. So I got an outage in progress. It's important. So VTP, the highest config revision always wins. If you disconnect switches from your net and configure them in a lab and reconnect them up, you need to be careful about it. You need to check the config revision before you plug them in, otherwise you might blow away your production V2p config. Now normally, in production, over time your production V2p domain will eventually get such a high config revision that it's not really a problem. But every now and then you might have a problem where every now and then you might plug a switch in as a hardware replacement if the VTP domain is the same and the config revision is higher on that switch. It could blow away production VLANs, and I've had buildings go down as a result. So V2p is sort of dangerous, but it has a big advantage because it keeps your VLANs in sync, which, as we saw in the last couple episodes, I had a lot of cases where I did not have all my VLANs on switch 2. I did not uniformly update the VLANs on all of my switches manually, and so I had redundancy problems. Okay, let's talk about V2p pruning. Show int trunk. Actually, I need to fix something. Here I am on switch 2, conf t int faz 0/1. I'll no shut it. Restore my redundancy to my environment. Show V2p status. Show V2p status is your friend. My V2p version is 2. My config revision is 20. I have 5 VLANs. My V2p domain name is lab. The only thing it doesn't tell you, which is critical, show VTP password. My VTP password is not configured, and it is not configured on all of my switches, so I'm uniform. Now let's talk about V2p pruning. We have a trunk. I have a bunch of trunks and a bunch of VLANs, and oh, and I still have this dangerous Bpdu filter out here. So int faz 0/1, spanning tree Bpdu filter enable. No. We'll give it a minute, everything a minute to stabilize. Actually, I need more than a minute to stabilize things. I'm still with that bad config revision 20, which didn't have any of the VLANs I needed for stuff to work. Const T, VLAN 2, VLAN 4, VLAN 5. VLAN 2 was so now I've created all those VLANs. Okay, so let's see. Show VLAN. Here I am on switch 3. I've created all those VLANs. Show int trunk. I have all the VLANs that exist. Okay, so one thing that's going on is my spanning tree root is on switch 1 for VLAN 1, but it's over on switch 2 for my other VLANs. And I think that's because when I deleted the VLANs, the spanning tree root command got deleted as well. That's new. I'll have to try that out. Let me fix it. Spanning tree VLAN 1-4096 root primary. Oh, 4094 is the maximum VLAN. Oh. So now I should, once spanning tree stabilizes, I should be spanning tree root on switch 1, which is my standard configuration. Okay, and here I am. I'm at switch 3, and everything is as it should be. My VLANs 1, 2, 4, and 5 exist, and my spanning tree forwarding state is all going out fast Ethernet 0/1 to switch 1. And let's go ahead and show V2p status, show V2p counters. That might be interesting. So I've been up for maybe an hour now, and I've received 33 summary advertisements. Those are the ones that I said come out about every 5 minutes or something like that. Maybe the timing's not precise. And then the number of summary advertisements that I've transmitted. Oh yeah, once every 5 minutes on each of my links. So that sounds about right. Let's go ahead and look back at my topology. I've got VLANs 1, 2, 4, and 5 in existence on all of my switches. So all of my trunks are carrying it. So any Ethernet broadcast is being flooded to all of my switches, regardless of whether I'm actually need VLAN 5 on switch 3. So show VLAN ID 5. So VLAN ID 5, the only ports on VLAN 5 are the uplinks. Whereas show VLAN ID 2, VLAN ID 2, fast Ethernet 0/1, 0/2, and I have a layer 3 interface on VLAN 2. Let me see what B2b Pruning does. Oh. Cannot modify pruning unless I'm in V2p server mode. Looks like V2p Pruning is a global thing that affects the whole V2p domain. Here I am on switch 1. Show V2p, conft V2p Pruning. So V2p Pruning is switched on. Show int trunk. And you can see what's changed here. This is the root bridge for all of my VLANs, and all of my VLANs go over to my backup root bridge, but down to my access bridge, I'm only sending VLANs 1 and 2 down there. Well, why is that? Well, VLAN 1 is special for pruning. VLAN 1 never gets pruned. VLAN 2, I have a layer 3 interface on switch 3, so it never gets pruned. And now the pruning has actually taken effect over to switch 2, which does not have anything in VLAN 2, 4, or 5. It pruned everything, whereas down to switch 3, where I have a VLAN interface where I have a layer 3 interface on VLAN 2, it pruned the VLANs 4 and 5. So what I've done here is, by just enabling V2p Pruning, the environment is dynamically decreasing the size of the flooding domain, which is making my network more efficient. But if I suddenly go and enable port something on VLAN 3 on switch 3, then it will just start enabling that. Let's go take a look at what switch 3's perspective is. Here I am on switch 3. Show V2p status. And you see V2p Pruning mode is now enabled, and my config revision is now up to 24. And show int trunk, and it on fast Ethernet 0/2 is blocking because it's going to the backup route. Fast Ethernet 0/1, it's VLANs allowed and active in forwarding domain, VLAN 1, VLAN 2, VLAN 4, VLAN 5, but only VLANs 1 and 2 are in forwarding state and not pruned. Let's see what the spanning tree says. Show spanning tree, VLAN 4. So VLAN 4 it still says, so for spanning tree purposes, fast Ethernet 0/1 is still forwarding because, so the spanning tree is not reconverged here, but VTP is dynamically, so spanning tree will still continue to go on all the trunks and run, so I won't take spanning tree reconvergences when I prune and deprune and stuff, but I simply won't forward traffic on VLANs 4 or 5 on this trunk because VTP has figured out that switch 3 does not need the traffic on VLANs 4 and 5. So VTP pruning is sort of a way to dynamically decrease the VLANs on those trunks as needed, and that's pretty cool when it works. Most of the stuff is pretty cool when it works. Okay, VTP is complex, so let's review everything we talked about today. Layer 3 VLAN, we have a layer 3 VLAN interface. It goes down when there's no layer 2 ports or trunks carrying that VLAN. We talked about the switch port trunk allowed command. VTP is the VTP trunking protocol. It has 3 versions, and version 1 and 2, version 2 are essentially the same. The default on these switches is version 2, and we're not talking about version 3 at this point. VTP mode, we have server mode, which is server and client mode both serve VTP information. However, as we saw, server mode is the only mode where you can create or delete VLANs. We did not show transparent mode. Transparent mode basically means it does not participate in V2P, but any VTP frames are multicast and will just go through it. So you could actually have switch 1. If switch 3 was in transparent mode, you could actually have it would actually forward VTP frames between switches 1 and 2 as if it were transparent. So that can surprise people sometimes. Off is a VTP mode which is only supported in CatOS, not in iOS. That's where it does not participate in VTP, and it does not forward VTP frames through the box. VTP, in order for the dynamic trunk protocol to run a trunk, the VTP domain has to be the same on both ends of the trunk. However, once you've negotiated a trunk, the trunk will stay up until the next time the port bounces. So that allows you to change VTP domain names in an entire environment without having all your trunks go down and come back up. But you got to be careful, because if your VTP domains or passwords get out of sync, then the next time, or at least if your VTP domain names get out of sync, then the next time the link flaps, the dynamic trunk protocol will not successfully renegotiate the trunk. And then we showed VTP pruning, which is where VTP will dynamically figure out that particular trunks don't need to carry traffic on VLANs because there's no access ports on those VLANs off the switch down there. So that way it'll decrease the amount of unicast flooding in your network, which is, or unicast flooding, or multicast flooding, or broadcast flooding in your network, which is pretty cool. Okay, let's step back a second, and that's how VTP works. Let's talk a little bit about how to deploy VTP in an environment. If you have multiple buildings in a network, typically each building, each large campus building would have 2 multi-layer switches where the uplinks are pure layer 3 and the downlinks and crosslinks are trunks. Now VTP only runs over trunks. So if you have multiple buildings like that, what you want is you want your VTP domains in the different buildings to have different VTP domain names. Now they won't talk VTP to each other because VTP does not talk through through pure layer 3 ports. But if a year down the line you had brought up a trunk between those 2 domains and they happen to have the same domain name, then whichever domain happened to have the highest configuration revision would win. In VTP, you always want to be careful about connecting different switches that have the same domain name. So in general, I name the domain name after the building, and that way we don't accidentally have some disaster where 50 VLANs get destroyed because 2 buildings happen to be completely separated, no 802.1q trunks between them, and then 2 years down the line, after you've created and deleted a bunch of VLANs in each environment, you reconnect them. and then whichever one is the highest config revision happens to win, and the other building has a bunch of its VLANs no longer exist, and a bunch of customers that are unable to work until you go in there and recreate the VLANs. Okay, so Vtp is cool. It lets you disseminate VLAN information. It lets you create it once on one switch, and it gets disseminated among all the switches in your environment. You might have zones with like 50 switches in them, so that saves you a lot of work. It improves your redundancy because you have consistent VLANs in existence on all your switches. Vtp pruning will dynamically not forward on particular VLANs on trunks when it's not necessary. But Vtp is also dangerous. Make sure that you don't connect a switch with a higher config revision number to your net without wiping out, without first resetting the config revision. In fact, let's do that. Let's figure out how to reset the configuration revision number. So here I am on switch 3. Show Vtp domain, show Vtp status, conf t Vtp domain. Right now my Vtp domain name is lab. Let's change it. Vtp domain Bob. Show Vtp status. Notice when I changed the Vtp domain name, the config revision went back to 0. But my VLANs still exist. Now I can change conf t Vtp domain lab. Show Vtp status. And I went and actually when I went back and became Vtp domain lab, I had config revision 0, and then the other switches out there immediately sent me an update saying, hey, here's the most up-to-date VLAN information. So that's how you reset the config revision. You just change the Vtp domain name and you can change it back. And that resets it to 0. In fact, let's, just to be sure, conf t int range fast 0/1-2, shut down. Show Vtp status, config revision 24, conf t Vtp domain Bob, show Vtp status, config revision 0, now conf t Vtp domain lab, show Vtp status, and you see my config revision is still 0 because my physical links connecting to the other switches are down, so there's no way those switches can send me the information. So by simply changing the Vtp domain name to something else and changing it back, you reset the config revision of 0, and now it's safe to plug this switch into my network. Let's go ahead and do that. Conf t int range fast 0/1-2, no shut. Show int trunk. My interfaces are coming up, my trunks are coming up. Show Vtp status. And now, just waited a few seconds, I got all the VLANs. Okay, so that's how to prepare a switch to be able to be plugged into your net nice and safely. You just change the Vtp domain name and you change it back, your config revision gets reset to 0. Meanwhile, your production environment has a high Vtp configuration revision. Okay, that's it for Vtp.